Record to cloud. Welcome everyone to the 6th annual Western Connecticut UFO Conference. My name is Aurelia Maraca. I'm the founder of this conference, and on behalf of the Danbury Library that we're transmitting from live, we welcome you here on this awesome Saturday morning, the day before Halloween. So let's get the spooky season going with Marc D'Antonio, and let's look up and let's investigate.
You got it. Thank you. Hey guys. Well, thank you for coming. I'll see you later. Oh, we're still starting. Okay. Thanks for coming out, whether virtual or real. We do have people here in the real world. I should turn the computer so you can see how many there are. There's Dennis and his son Dennis. But it's raining, people aren't going to come out. Yeah. One of the interesting things is that there's a lot going on in the world right now. And one of the things that you should be on the lookout for tomorrow, if it's clear where you are, and it's just even partly cloudy, tomorrow is Halloween. And I won't howl like a wolf or anything, but we had a coronal mass ejection leave the sun a couple days ago, and it's striking the Earth tonight into tomorrow night. So what's going to happen is tomorrow night, you may see for the first time in decades, Aurora Borealis right over your head here in Connecticut, if you're in Connecticut or New York State. So that's something to look for. I'll be live on the air with KGRA, where I have a radio show from 6 to 8 on Sunday nights. And we're going to be streaming the auroras live. And if it's not clear here in Connecticut, where I live, then it's going to be clear in Lapland, where I'm going to borrow a stream from. That's always a live stream, and you'll be able to see the auroras just dancing all over the sky there. It's just wonderful. So already, we have something cool happening tomorrow. But auroras are interesting because they're charged particles from the sun called the solar wind will come here, enter our atmosphere, swirl around, and they interact with the nitrogen and the oxygen in our atmosphere, and they cause those molecules to glow. That glow is characteristically green, and it's red at times. And so we see those. Now, I get a lot of people that will report auroras as a weird UFO object because they don't know what it is. Believe it or not, there are people who have never seen, that's not that hard to believe because you only see them in northern latitudes. But when people see them, they actually think that there's something other than a natural occurrence. And that's fair, because if you've never seen them, you would. When I was a kid, I actually saw this amazing auroral display in the sky, but it was very focused into one spot, like a little sphere in the sky. And I looked at that and I said, wow, what is that? I called the alert network. I was actually like 12. So I guess I still don't really have a life because I'm to do this. It's crazy. But I called, and the people there said, well, and I was in Connecticut here. And they said, well, a rocket was launched from Virginia up into the ionosphere, and it blew out a load of chemicals, they said, to make the sky glow. That was how they explained it to me as a 12-year-old. But I was just hooked on auroras from that point on, and they said they made an artificial aurora. That was cool. So that was kind of a neat thing, These types of things are rare. So if you get a chance tomorrow to see it, check it out, will you? Go outside after dark. It doesn't have to be 1 a.m. It's not like meteor showers, which are best after midnight. The auroras are going to happen, if they're going to happen, they're going to happen from like, I'd say 10 p.m. to 2 a.m. And probably beyond. Earlier in the evening, the better, because it's going to be striking primarily later on tonight into tomorrow. So I hope you enjoy that. Now, today's talk is actually a talk that I'm doing because I'd like to share with you some basics in astronomy and then show you some other things. So we're gonna crank ahead. And Aurelia, how much time do I have?
You have about 1 hour.
I have about 1 hour, so that means 1 hour and 20 minutes. Just kidding. But anyway, let's start with the obvious, and that's stars. Okay, stars we see every night on a clear night. and these stars are many different colors, and except green, and that's a whole nother thing. There are no green stars, and that has to do with how stars radiate their energy, but that's a different talk. So when we look in the sky, okay, we see this. This is called the Hertz-Sprung-Russell diagram. And are they going to see my cursor by chance?
Yes, they are.
Okay, good. Okay, so if you look down this snaky line right here, okay, this snaky line is called the main sequence. What's that? Well, that's where stars like the sun are. Normal stars will take hydrogen, which is their main fuel, and convert it to helium, basically. Well, when the stars do that, and we look at their color versus their brightness, they all seem to follow a line like this. That line is a line that all stars doing this normal hydrogen to helium fusing of elements will show up. But what are these then? These stars up here are stars that have been here but left because they stopped fusing hydrogen into helium, and they ran out of hydrogen in their core. And so they started taking the helium in their core and making it into carbon, and carbon into nitrogen and oxygen and so forth and so on. And the biggest stars like these will appear, these hot blue stars, which are O's. Down here you see O and B. Those are letters we designate for the spectral class of a star. The O and the B stars will be making hydrogen into helium, and then helium to carbon, and they'll start making elements all the way to iron, which is number 26 in the periodic table. Well, who cares? But what that tells you is that the bigger stars can make elements all the way to iron. But then what happens to those big stars? They explode when they run out of their final fuel. The reason is because there's so much outward pressure from the radiation that's pushing out on these stars. Okay, the radiation pushing out as they fuse elements, that if it stops, the gravity collapses that star very quickly. And these big stars, which if you put them where the sun was, could go all the way out past Earth and Mars in some cases, even Jupiter in the most extreme cases. The star's core will collapse in about 1/4 of a second. All right, and when that happens, all the rest of the envelope of the star stuff is starting to collapse. And when that core collapses, it hits the iron that's in the middle, and the iron can't be compressed anymore, so it bounces off. And now the rest of these stuff is coming in, and that stuff's bouncing and pulling out, and so the whole star is getting this huge force outward with a huge force inward. And what's that do? Boom! That causes the star to blow up, and that's called a supernova. And that's what these supergiant stars up here will end up becoming. And actually, these giants down here can do that as well. So the stars are very interesting. They come in a variety of colors. Hottest and bluest is the O stars, as I mentioned, and the coolest and the smallest are the M stars. Now, the M stars, these little guys, I call them percolators of the universe. They can just go on and on and on, and they will create energy and fuse hydrogen into helium for literally trillions of years. They're small, sometimes only a little bigger than Jupiter. That's pretty cool. And then when they die, they swell up into a red giant, and then they will slowly collapse and become white dwarfs, which you see down below. Okay, the sun is going to do that same thing, just be a little bit of a bigger red giant, and then it'll collapse and become a white dwarf. These stars to the left of the sun, many are going to grow into red giants and go into supernovae, but some of them, if they're smaller, might be able to go into a white dwarf, but you're not going to get that with these O's and the B's. Maybe with an A and an F, okay, but you're never going to get that with O and B. O and B, they're the supernova generators of the universe. They will create this tremendous amount of stuff that goes blazing through the universe when they go. And when you look out in space, you see lots of dust. You see lots of gas. A lot of it comes from those very stars. Billions of years of supernovae. And it's hard to believe that, but we can tell that that's where that comes from. You know, some of it, some of the hydrogen, which is the most plentiful element in the universe, was there from day one, but some of it was not. All of the dust wasn't. All of the black dust we see, and it's actually brown, in our galaxy, we have these dust lanes in galaxies that make you see the spiral arms and you see these dark lanes. Well, those are all the result of supernovae and the result of red supergiants that are actually pulsating and pushing off some of their atmosphere, and they actually make soot, effectively carbon atoms in the outside of their atmosphere, which leave, and that stuff over time has populated the universe. It's amazing how much stuff is out there, you know. So that's the interesting thing. This is Orion, as taken from our Arizona Observatory, and Orion is an interesting constellation. In the upper left of Orion, we have that red star Betelgeuse, and that blue arrow points to where Betelgeuse is on our diagram we talked about. Okay, Betelgeuse is not on the main sequence. It's not in the squiggly line here. It's actually, you know, way off there. It stopped burning hydrogen, or fusing hydrogen to helium years and years, many millions of years ago. But not that many millions of years ago, because it used to be one of these stars right here. It used to be one of these O stars, very hot and very blue. But then it migrated off this main sequence once it began to swell and start fusing other stuff. And it's going to go supernova if it hasn't already. And I say that because it's about 750 light years away. I mean, we see it as it was 750 years ago. So if it went supernova like 749 years ago, well, then this year we'll see it happen, because the light train is just going to get to us from when that happened. So, and that's an interesting thing about the universe. Every time you look at the universe, you're looking back in time. Every single star in this picture is seen at a different time in the life of the universe, right? You're seeing Betelgeuse 750 years ago, right? So, you know, so that tells you that the universe is like a giant time machine. You're not seeing any of it currently as it is. Even the sun, you're seeing the sun 8 minutes ago. Isn't that weird? But it's true. So Betelgeuse is going to explode in a supernova someday, which looks kind of like this if you, in this artist rendering. Okay, so that's going to litter the cosmos with these beautiful elements, these amazing contents. And when the supernova actually occurs, more elements are going to be spewed to the universe. You know, down on the lower right part of Orion, we have Rigel, which is this beautiful blue, hot blue star, and you can see the blue arrow pointing to where it comes from. Here, it's also left the main sequence, but Rigel has a destiny similar to Betelgeuse. It's going to go supernova eventually. Now, then we have Alnatak, which is this star here in the leftmost star in the belt. Okay, Alnatak is also in the same relative region as Rigel was. Now, Alnatak is only a few million years old. And when Lucy, the pre-ancestor to humans, you know, Australopithecus afarensis was the official name. When Lucy was wandering around Aldovai Gorge as a little tiny 3.5 foot tall hominid, this star didn't exist. In fact, it's very possible that if Lucy looked up in the sky in her winter and looked into the constellation of Orion, Betelgeuse would have been a hot blue star, as seen by Lucy. This star wouldn't even have been here. So Orion wouldn't look anything like it does today. So the universe doesn't always stay the same. It's changing right before our eyes all the time. Now, if we move forward, okay, so the question becomes, what do we see in the night sky? All right. And well, we see aircraft, all right. And then we're going to Earth now. We're going to say, like, we come on down on Earth, what do we see when we look up in the sky? All right. Well, we see aircraft, all right, and they're very recognizable. Does that look like a plane to you? It is. It's just a time exposure. It's a multi-second exposure. And for those who are clever, the Federal Aviation Administration says that the wingtip strobes on the end of the plane, which are momentary flashes, one here, one here, one here, one here, one here, and one here. 1, 2, 3, 4, 5, 6, and a little more. 6 flashes. Well, the FAA mandates that you will have 1 flash a second. So this exposure was just over 6 seconds long. You can tell because you got time to see 6 flashes. Same thing for this red dot here. The red dot is that belly strobe on the bottom of the plane, right? And we almost got another one, 1, 2, 3, 4, 5. We almost got to a 6th one, and it's just a little bit beyond. We just didn't quite get it. So not bad. So this is a plane. Okay, so if someone gives you this and says, I photographed this thing in the sky, and this is exactly what it looked like. Now you know that you should probably look at it and say, well, how long was the exposure? And if it was more than a fraction of a second, then you know it was a time exposure, and so you know they didn't see what they would claim. And that's, as a UFO investigator, that's the kind of stuff you would do, you know. Now, as I just pointed out, there are this long constant lines here. These are the lights that are always on the wingtips of the planes, right? And the red light, you have the strobes, but you also have the red and green lights at the wingtip, which are kind of lost here. You do get the red light on the belly strobes, and we do see those bright flashes of the wingtip strobes, which you've seen too when you fly in a plane and you're coming down and it's cloudy. All of a sudden the plane's lighting up because it's like these strobes are so bright, they illuminate the clouds around them, and you see that. So it's pretty neat. Now we also see meteors, we see satellites, and we see comets. All right, now let's talk about meteors. Okay, meteors are, well, they're quite high up. They're 90 or more miles up in the air, and they have different colors, as you see here. Okay, the most common one you're going to see is this yellow one, iron. I have an iron meteorite that's about this big. It weighs, oh gosh, a couple of pounds. And they're very common. But of course, at that size, that's kind of rare. But you know, you do see a lot of these meteorites. And when the meteor's entering the Earth's atmosphere, it's burning up, and it ends up, as it burns up, it might make it to the ground. If it makes it to the ground, then when it strikes the ground, you can find it. And this one that I have was found in Argentina. And the colors are due to the chemical elements inside the meteorite, right? So you can see sodium is going to burn with a yellowish orange. Iron will burn with this yellow. So there's a lot going on here, a lot of things for different colors. So they can be very fast streaks, or you can see a trail that leaves smoke behind it that goes for many and stays there for minutes. Okay, for instance, here is one crossing in the sky. That's a trail you see right down here at the bottom. All right, and Chelyabinsk in Russia is a famous one from 2013. It happened in February of 2013. It was a house-sized meteor that entered the Earth's atmosphere and started to burn up. And when it hit what I call it the atmospheric wall, it gets down to a certain height, and it's moving so fast that the air is getting thicker and thicker and thicker, and it overwhelms the structural integrity of the meteor. So the meteor just explodes. Again, it's moving at many times the speed of sound when it comes in. Sometimes it's moving somewhere in the order of 30,000 kilometers an hour, 11,000 kilometers an hour. That's fast. And it gets to the atmosphere in just seconds. So there was a tremendous amount of shock waves and injuries, many windows destroyed in that event. Incredible, you know. So sometimes the universe can be pretty darn dramatic. We, in our telescope, here you see, this is me down here in our dome operations, and here's the telescopes in our dome. We were doing the lunar eclipse back in 2019, live stream. And we saw this white dot appear on the moon, right in the middle of the eclipse. You know what that is? It's a meteor striking the moon. and we were one of 6 people, a total of 6 groups on the Earth saw it. And we were one of them. That is something that was really, really incredible. I attributed it, when I saw it, I thought maybe it was a video glitch. I just didn't consider that we might have caught something exceedingly rare, and we did. So that was pretty cool. So the universe is dynamic and changing all the time. And we also see satellites, okay? And satellites are generally they're slow moving. They move across the sky like this. You might see them move across the sky. The International Space Station is the brightest. It's a yellowish color, and that's because the solar panels on the space station are a copper color, orange yellow, that might show up that way with the reflected light. So that's what you see. And other satellites, you can see them, but they come on and they seem to go off. They come on and they go off. What would cause that? What would cause that is if the satellite was tumbling. And there are satellites that tumble. As they tumble, they put and here you see the bright satellite, but then as it tumbles this way, you see it's not as bright. Then it tumbles this way, and that's much brighter, and so on and so forth. And these tumblers that we call them, those are neat to see too in photographs, because you get like dashes on a photograph if you take a long time exposure. They can move in pairs, and the Navy has put up some satellites that move in triplets, so you actually see 3. And let me tell you, I get a lot of calls. I just saw a triangular ship in the sky, moving across the sky. And I look back and I look at the data, and I see, well, yeah, this Navy reconnaissance satellite triplet just went over your place at this time. Did you see it then? Yeah. Well, yeah, that was 3 satellites, but it was solid in the middle, and that's the illusion that your eyes portray, because you think it must be solid, and so you fill it in mentally. We've seen this very same thing until a star went through the middle, and then you realize, wow, that's actually 3 separate objects. Satellites also don't twinkle like stars, and that's the coolest thing. Okay, that way you know that's what they are. And they do appear, as it says, as solid lines that taper off, because as they come across the Earth's terminator from their altitude, you'll see them kind of slowly get brighter, and then as they cross through, they get past the shadow of the Earth, and then they start to slowly dim out. All right, here's an example. That's a satellite. This is actually a short streak, and this is actually called an Iridium Flasher. There were these Iridium satellites that were very, very bright panels, and they would reflect the glare down onto the Earth. And as that glare moves across the planet, you can predict where it's going to be. And so you can put yourself in the path of the glare and then capture the glare. There's very few Iridium satellites anymore. In fact, they're called the Constellation. A bunch of them are being taken out of service, so they'll be deorbited and dumped into the southern Indian Ocean, which is the satellite graveyard. Bet you didn't know that. There's more satellites on the ocean floor of the southern Indian Ocean than anywhere else on the planet. Okay, but then there's this guy down here. What's that fuzzy thing? Well, that fuzzy thing is a comet. Okay, here is Comet Neowise, Neowise. We did this in SkyTour LiveStream East, our Eastern Observatory. We had an audience of probably 1,000 people watching at the time. And if you notice, the head of the comet down here, see these 2 little stars down here? You notice how the head of the comet is moving as this goes on? It's moving. This is over 45 minutes. You see it moving. We're actually watching the comet move through space. Okay? And you see the tail of the comet. There's 2 tails. This tail here is an ion tail. It's blue, and then this is a dust tail. So there's a lot of really cool stuff in the night sky to see. All right. But let's just talk real quick now about constellations and some of the anomalies here. Let's just this is a simplified chart. Really what you want to take away from here is we are going to look at our skies at different times of the seasons. Okay, right now at 9 p.m. at night, you could look up and see, this is the southern horizon down here. You can look up and see the Great Square of Pegasus, okay? And this Great Square of Pegasus is over your head. And you're not gonna, this is sort of a dim season. Pegasus is the only thing you're gonna see. And it's a fairly big constellation in your night sky. At arm's length, it's gonna be like this big in your sky, all right? And to the right and upper right of Cygnus, that Great Square, if you're looking up at the Great Square of Pegasus, over there is going to be Lyra and right here, and Cygnus, the swan, Lyra is the harp, and then we have Aquila, the eagle, down here. Now, we'll get to that in a minute, but the Great Square of Pegasus and this sky has some really interesting stuff in it, including this. We took this picture. This is a 20-second photograph from our SkyTour LiveStream East telescope. That's the Andromeda Galaxy. It has about 1 trillion stars in it compared to our 150 billion. I know, trillion, billion, but you know what? It's a much bigger galaxy than ours. Oh, and by the way, it's hitting right for us. It's going to hit us in about 2 billion years. And when I say hit us, it's going to pass through us, and we're not even going to know what happened. No, that doesn't mean it's going to wipe us out. It means that we're just not going to even know what happened. If you weren't an astronomer and you weren't looking up into the sky and you didn't see any of this, you'd go on with your day. In fact, you know, millenniums of humans will go on with their day and not even know what happened, because nothing's going to change. Why is that? How can that possibly be? Because the stars are so far apart that they're just going to pass through each other, and know what's going to happen. There will be gravitational attractions, and some of the stars from the Andromeda Galaxy are going to be trapped in our galaxy. Most of the stars in our galaxy are going to get absorbed into the Andromeda Galaxy, and over time, the galaxies are going to kind of do this together and kind of move. If we look at it in fast motion, it's going to kind of do this and mold into some new type of galaxy, you know. But nothing is going to be wiped out. There won't be any cataclysms and no major extinction events because of that. We have a higher chance of getting, you know, hit by an asteroid by far than being killed by a galactic collision. You know, now if we look in the northern sky, okay, okay, let me I have to just do that. Okay, if we look toward the north, all right, you'll see that we have the North Star with the blue arrow. Okay, and look where the Big Dipper is. The Big Dipper is holding water down at the bottom there. That's the Big Dipper is actually a pattern of stars within the constellation of the Great Bear called Ursa Major. And this is your sky now. The Big Dipper is like down at the bottom underneath the North Star, okay? And up over your head is Cygnus, Lyra, and Aquila, right? Now, unfortunately, you can't see Aquila because of this bar up here. So I am sorry about that. Is there any way for me to remove that bar at the top?
I think you can just move it.
Can I move it? I'd like to just move it. Hang on, guys. I'm trying to figure something out here. Let me look under here. I'm not going to pause recording. I'm not going to do that. Do I hide video panel? Yeah, I don't want to wipe something out. Hide floating meeting controls. Isn't that what it is? Where are we looking?
Let me try. Hold on a second. Sorry.
Sorry, guys. Aurelio's causing problems. Wait, how'd you move that? Where'd you touch that?
It's called magic. Ooh, magic.
Can I make that go away?
I think we can't. I don't know. I'm not that Zoom savvy, but
I've used Zoom, but I use StreamYard.
I think you can just move it about, you know, unless we want to accidentally interrupt the transmission from the Danbury Library to the folks at home.
No, I don't want to accidentally interrupt anything. I'll leave it up here.
Okay.
All right. Okay. Sorry, guys. I don't even think you guys saw that. I think I see it. So here's the question. When it comes down to this, you know, when we look toward the north in the fall sky, we're going to see the North Star, and North Star in Connecticut is going to be, you know, about 41 degrees up into the sky. So not quite 45, which is half of 90, which is straight overhead. So it's going to be a little less than that 45. And it'll be toward the north. And it's going to be one of the brighter stars in the north, but it's not a bright star, just brighter than some of the others, okay? And then we're going to see Cygnus up here, the Swan, that's a Northern Cross. And we'll see Lyra, okay? But we'll see that again in a better way momentarily. So that's the fall sky. Now, In our winter sky, all right, now we just looked at the fall sky. So in our winter sky, looking south, this is where we see Orion. We just poked around at Orion here and checked it out. And to the upper right of Orion, we have Taurus the Bull. You see this bright V of stars with this one here. This is an orange star called Aldebaran. It's really pretty. And to its right are the Pleiades. The Pleiades are the seven sisters. They are a really cool constellation. You see them on the front of Subarus. Okay, Subaru is a word that means unity, approximately, in Japanese. And Subaru is what they named the car because the Pleiades are sort of a unified little cluster of stars. They're all the same kind. So it's sort of a unification thing. It looks really nice. So from Orion, you're not going to see lines either in the sky. So you're going to look for the beautiful orange star in the upper left of Orion, the belt of three. And then to the upper left here, if you draw a line from the middle star of Orion's belt through Betelgeuse, you're going to come all the way up here and see Castor and Pollux, the two Gemini twins, right? And then if you go straight up through Orion, and here you're going to be going up over your head, okay? Then you're going to see Auriga, all right, here. And this bright star is called Capella. And these are the beautiful winter constellations. Orion, just below the center of the belt there, right below the belt of three, there is an area right there, which you can't really see too well in this rendering. We'll see it after. That's the sword of Orion in the mythology. And that sword contains a nebula, one of the few that you can see with your eye. And that is the Great Orion Nebula. And we have taken many pictures of the Great Orion Nebula. It's just beautiful. Okay, so that is looking up north, right? And I'm sorry, south. Now, if we look up north, okay, we'll see the other end of that, which I'll show you. But this is the Orion Nebula that we took with the SkyTour LiveStream East cameras. And that's a beautiful star forming region. We see more stars forming in there than in a lot of other places. It's also only like 1,600 light years from us. So you're seeing this 1,600 years ago, but you're seeing it in a position where we're actually seeing stars that are in the process of being formed. They might already be formed by this very instant, but we can't see it. We won't see it for 1,600 years, you know? So that said, if we go north in the winter sky, here's our North Star again down here. But now look where the Big Dipper is. The Big Dipper is sort of spilling out, okay? These times are for like 9 o'clock in the evening, all right? And now Orion is up here because we're just turning around and looking to the north, kind of a thing, all right? So it's the opposite side. And that signifies winter's approaching, okay? Now, when spring approaches, we are in what we call galaxy season, because this constellation of Leo and Coma Berenices and Virgo are constellations that have a very, very high amount of galactic population. There's so many galaxies here. And of course, we're looking at all those galaxies through our own galaxy. It's like being in a forest and looking out at distant hills. Okay, well, the distant hills for us are these constellations. And the forest are all the stars that we see here that are in our own galaxy, right? And there's many different galaxies in that sky, including these, this one. And we're seeing it through stars of our own galaxy, right? So there's a lot of different wonders out there. Again, this particular photo was only about 20 seconds long. Now, if we look to the north in the spring sky, this band of the Milky Way is here, okay? Now, in the spring sky, the Big Dipper is up top, up high at 9 p.m. So if you see the North Star, look at the Big Dipper, and these two end stars in the Big Dipper point to the North Star. And that's neat. That's something I think you would be more than capable of doing, actually. So you should try it. Try finding the Big Dipper. It's going to be hard now because the Big Dipper is kind of low. It's below the North Star. So if you don't have a northern horizon view, you might not even see it. Okay. And then the reason I'm rushing this is because I got some good stuff for you coming up. Now we're in the summer sky looking south. Now, we just went through the summer sky with SkyTour LiveStream West, which is our Arizona Observatory that's in the desert out west. And we took some stunning photos, which I'll show you of the night sky there. And you're all free to join. It's a free thing, and the photos are made available within minutes of taking the pictures. They're automatically shipped up to the cloud where you can grab them, right? But see, here's what we got. I talked about Cygnus the Swan. This is Deneb right here. Deneb means tail of this, means end, you know, and this is the end of the swan. This is the head of the swan right here. It's a beautiful double star called Albireo, and these are the wings. It's also known as the Northern Cross. And Deneb is beautifully matched with Lyra over here, this little constellation here, which has a bright star called Vega, and then these two stars here. And then we have Aquila the Eagle down here, wings, and of course, head and neck. And this here is Altair. This is a star in the middle of its body. And together, these three stars form what we call the summer triangle, outlined in purple here, or blue. And so we have Deneb, Vega, and Altair. And when you see those three stars, the Milky Way runs between them. A river runs through it, okay? And that river is, of course, the Milky band of stars that we call the Milky Way. So that is our summer sky there. And here is one of the things we see in the summer sky. This is actually a supernova remnant, a remnant of a star that exploded. Remember I talked about those big stars? Remember I talked about how Betelgeuse is going to eventually explode? Well, it's going to create a nebula like this here. Okay, this is just one side, and it's expanding outward. It's an expanding shell coming out from this explosion center. So some's coming toward us, some's going away from us, all directions. This thing here is probably this gigantic swath of an arc like this that's moving out and expanding as it does so. It's very hot, and that's why it's glowing. These atoms that are in here have been ionized, meaning that their electrons are blasted off the atom for a period of time, and then they recombine. And when they come back to the atom, they give off light. Oxygen gives off this greenish blue light, and hydrogen gives off this red light. So that's a cool, a very interesting thing that we see. This is, again, is a 20-second exposure. And that one we took here in Connecticut under light polluted skies. We use special filters to cut through all the light pollution. Out west, we don't need filters for light pollution because the sky is just stunning. Okay, so the summer sky toward the north, all right, if you look, here is the Big Dipper right here, and it's on its left side now. So you watch it go all the way around the pole, right? And it never sets from the northern hemisphere because it's just not close enough to the pole, or not far enough from the pole so that it goes below the horizon, okay? So it's called circumpolar. It stays up all year round. So you can kind of use it as a target to figure out where you are. So at 9 o'clock at night, you look for the Big Dipper, and you can kind of guess what season it is. I think your iPhone or your Android phone or your calendar would probably give you that information as well. But it's fun to do it on your own, let me tell you. If I go out in the woods at night and they drop me in the middle of the woods and I don't know where I am, I can't get lost as long as it's clear. If it's clear, I can look up, and the stars right over your head are at your latitude. And if you know what those stars are, then you know where you are on the planet up and down, right? The latitude. And if you know what time it is, then you know where you are on the planet based on where the stars are. That's really kind of cool. And it doesn't take that much time to figure that stuff out. So I learned that when I was a Cub Scout, for crying out loud, back in the years when I was just a kid. So that was cool. And now the fun things. I'm going to go with an iPhone because that's what I have. I want you guys to be able to walk away with something. Okay. So here are some applications that I know that you'd really like. Okay. Okay. The first one we're going to talk about is Sky Guide. How many of you have Sky Guide? Raise your hands. Oh, I can't see you. Anybody here have Sky Guide? Okay. One. Now you're going to have Sky Guide probably next 5 minutes. Yeah. Sky Guide is really neat. And the reason is because Sky Guide gives you the ability to look and zoom into different areas of the sky. Look how detailed. This is the Orion region. Look at that. I mean, that's the ordinary Sky Guide. if you get what's called supermassive, which is a subscription add-on, you can zoom into the Orion Nebula until you see individual filaments and go right even close to just a haze of red. I mean, for just certain areas. For an astronomer, that makes sense, but maybe for you it doesn't. I don't know, unless you're an astronomer. So it's kind of cool. So Sky Guide, right? Mark that down. Sky Guide, you want that. Promise. Right? And then what's that satellite going over your head? Well, and by the way, Sky Guide is available in Android and for iPhone, I believe. And then we have GoSat Watch. GoSat Watch is a satellite program which allows you to basically lift your phone up if you want to. You don't have to. And it will orient the sky and show you what the satellites are looking over your head. That's cool stuff. It's not augmented reality where it takes a photograph or anything, because you're usually looking at night, right? But that's neat. So Sky Guide and GoSat Watch are very cool. And you can also get predicted satellite passes. See, so these are the passes, and it tells you when the satellite is going to rise, okay, and tells you where it's going to be from your location and how bright it's going to be. These numbers stand for magnitude. And what is 3.9? Well, your eye in a light polluted area, you can see to about magnitude 4.5, maybe 5. In the city, you probably can't see past 2 or 3, maybe 3. But out in the countryside, you can see almost to 6. So that gives you an idea. The moon is minus 13. The numbers go negative 2. Sun is minus 26. Right. So Vega, for instance, in the summer sky, that star Vega is a part of the summer triangle. That's magnitude 0. Okay. And then negative is even brighter and positive is fainter. It's kind of weird, right? Astronomers, we love the confusion. So that's a good one. GoSat Watch. Another one, if you want to know about stuff in the sky, it's called theodolite. As complicated as this looks, there's so much to this that you can use to record information. All you have to do is point your camera and click, and you've recorded a ton of data. All right. Theodolite is an excellent app for that kind of thing. It does cost money, though. I think this one's $10, but you have it for life. And it's really a really good application. Another one, if you want to investigate UFOs, you can get this. All right. This is called Toolbox. And it has a whole bunch of things: a Tesla meter, a compass, a plumb bob, a decibel meter, a metronome, altimeter, barometer, protractor, ruler, spirit level, surface level, seismometer, stopwatch, and timers of all kinds. Usually what you use this for is the Tesla meter. Here we can actually measure the magnetic field, all right, in microteslas. That's what that little symbol up there means right there. You see the micro is that U is a micro, like micrometer. Micro and capital T is Tesla, micro Tesla, right? And so you watch this go like this. And so if you go to a place where there was a UFO and you just take out your Tesla meter and pass it around, you can record the magnetic field variations in that area. So that's a really cool tool as well. It's called Toolbox. There's a lot more in there. Now, another one you want is dark sky. If you're interested in getting to a place where there's a dark sky, this shows you in terms of what's called the Bortle scale, B-O-R-T-L-E, down there at the bottom. A 1, 2, and a 3 are the best skies you want to be in. 4, 5, 6, 7, 8, 9. Well, you know, as you get closer to civilization, they just necessarily go up because there's more lights and street lights. Okay, so that's unfortunate, but it's called dark sky. It's a great application. And here is where our Western Observatory is. It's out there in the 2 to 3 range. And let me tell you, it's beautiful. But Phoenix, way down here on the right, is like 65 or more miles away from us. With our sensitive cameras, you can actually see a dome of light from Phoenix on those cameras, even out there. Luckily, we don't look that way, so we're cool. Now, another one, oh, sorry, I gotta do one more. Actually, we're gonna be teaching, where I'm gonna be teaching astronomy is in this exact spot next week for the Phoenix Mutual UFO Network Boot Camp. And here, the sky is beautiful looking this way, but back this way, it's really bright. See, so the sky in certain directions might be good, and it shows in bands. So you look this way, or this way to this way, you're cool, but this way, it's not good. So this is good to help you find a location to go observe with a telescope, or just with your binoculars, or just by eye. For those that like the moon, this guy, Moon Globe HD. Oh, this is fun. You can look at the moon as it is in the sky right now, for instance, and look at all the craters. You can zoom in on these, and you can also go to an area. Just with a click of a button, you can actually go to a spot where you can, or part of the program where you can actually rotate the moon in 3D and explore the far side of the moon and the near side of the moon. Zoom in and check out things from different angles. It's really quite nice. Moon Globe HD, and you can also see where, well, for instance, the Apollo 11 landed, where other craft landed that we put up. And again, this is not a CG moon. This is real data of the moon that's been placed in this app. So Moon Globe HD, really good app. And then for those that like to do the kind of research that I do, which is exoplanet research, this is a Exoplanet, written by Hanno Rain, is a database of planets around other stars. It gives you a tremendous view into the data. And basically what you can do, you can see how it was found, you can see what kind of star it was, you can see how big it is relative to Earth, you can see where it is in the sky, and more, and more. So that's a great app too. Now, I mentioned we do public outreach. Well, we do actually do public outreach. SkyTour LiveStream is our observatory. This is the former observatory that I had here in Connecticut. I got rid of the dome because we outgrew it. So I'm rebuilding it as a much larger building, and it's going to have a roof that's going to articulate like this and just come off the building. The one out in the desert slides off and then slides on, and we have room for 3 telescopes in there. We currently have 1. So SkyTour LiveStream is on YouTube. It's live on clear nights. And we've been doing a lot with the Arizona Observatory lately. And so it's, well, this is what we do. We look at very faint objects in the sky. And we're part of a triple team. We're part of another streaming guy who's called Bill New York Skywatcher. He looks at the meteor showers. And tomorrow night, he'll be doing the auroras, if it's clear, as will we. And then there is P&K Space Imaging. They do the moon. And note that's Paula Keith. And they do the moon better than anyone can do the moon. So between P&K Space Imaging, Bill New York Skywatcher, and of course us, SkyTour LiveStream, you have your deep sky, you have your planets and the moon, and you have your meteor showers and your auroras. You can't get a better combination. So you might want to check those out. Okay. And we're on YouTube, we're on Facebook, astroimaginglive.com. Here is the Arizona Observatory. That's what it looks like. The door was made by an Arizona artist named Tara. And Tara made this entire door, complete with our logo, out of colored bottle caps. It's really cool. And to open the door, the handle is the bottle opener. It's the coolest thing. I gave her free license to do whatever she wanted, and she did that. I thought it was the coolest thing. You know, that whole door, by the way, that whole roof moves off. Very simple. I just said, look, it's almost like a garage door, but we're just not going around a curve. We're just going straight. So we don't have springs in the door or anything to help it come back up the curve. It's just a garage door opener that takes it off and brings it back on. That garage door opener will last 100 years, you know, so we're good. We have a vent in the roof because it gets hot out there. We've had temperatures inside the building of about 120 or more. You know, so we have a vent that takes the hot air out after it reaches 100 degrees. And the telescope is perfectly fine at 100-degree temperatures. It's really neat. So what do we do? Wait, this is our sky in Arizona. This is the night sky, right? That is, okay, if you look down here, it's a 40, down the lower left, it's a 45-second exposure. We did that in April, and it was 4:31 in the morning when I took this picture. So we have a little bit of a mix of this is east over here. This is the eastern horizon. So this part of the eastern horizon right here, that's the glow from Phoenix, 65 miles away. The rest of this glow is dawn approaching. Okay. Remember we talked about satellites and meteors? Well, here's a satellite right here. There's a satellite coming through and winking out. Okay. And this is the Milky Way is seen. It's horizon to horizon. You see this with your eye, by the way. It's just beautiful. This is 180 degrees. So this is east, this is west, this is south, south at the top and north at the bottom. And just incredible. All right. So we see satellites and the Milky Way from there. We also see oddities. Who sees the oddity in this image? That's right. A gigantic black spider monster attacking Phoenix, and we caught it. Oh no. Actually, this curved object here. On the previous frame, it does this. It's on the other side. I have no idea what this is, and it's a true anomaly. It's not an aircraft of any conventional kind, because if it was like a military jet, let's say it was, where are the engines on a military jet? They're at the back end, right? So you can imagine as a military jet's going flying away from you, you'll see those engines, and you'll see that engine glow. But if it turns and starts going around, those engines are on the backside. You're not going to see the glow, and you're going to say, "Oh, well, that's just what we see here," as I did too. But the previous frame shows the other half of this circle. This, if you look down here, it's a 24-second exposure, meaning that it took 48 seconds for this object to make a complete circle. And even though it's a wide-angle view, some may think, well, it's a wide-angle view, so it's distorted. This camera isn't going to distort like that. It doesn't do that at all. This is exactly what it looked like in the sky. The spider looks just like that. He was on the dome of the all sky cam, right? So that circular thing is a true oddity. So what we do is we capture a lot of oddities out there too. The other night we were doing a live stream, and during the live stream we saw probably no less than 25 satellites that go right through the field of view that we're looking at. That's a lot of satellites. So we capture oddities, which are really cool. And then we have something else. This photo was taken at 8:38:44. That's 8 p.m. Okay, on April 29th. And then we see something odd. We see this strange light right here. You also see a satellite. That's very faint trail here. Okay, you'll see one in almost every shot you take out there. You'll see satellites. You know what this is? This is diacal light. You know what that is? That is light pollution. But it's light pollution by our solar system. It's not light pollution from a city or an earthbound thing. It's actually from our solar system. That is the disk of the solar system illuminated by the sun. All the dust in the solar system illuminated. That's the zodiacal light that we're seeing right there. And that zodiacal light, when I first saw it, I got mad because I'm thinking, what? Who's got lights on? Oh my gosh, I can't believe it. I was looking with a night vision system, and I'm looking at this light saying, oh man, somebody's got lights on somewhere. And I'm thinking, did I pick the wrong place for this observatory? You know, I wasn't thinking. Then I wait a minute, that's the western horizon. Could that be zodiacal light? Yes, it can. And that's the exact slant that we would expect because Earth's tilted on its axis. So when you look at it, it's going to be at an angle, and that's exactly the angle it's at. So yes, that is the zodiacal light. That's the reflection of the billions and billions of particles of dust in our solar system as illuminated by our sun. That's pretty cool. You know, so in the northern side of the sky, we take pictures like this. This is the Bubble Nebula. This is a phenomenal little feature because this star right here is what's called a Wolf-Rayet star. Wolf like the animal, Rayet, R-A-Y-E-T. And this Wolf-Rayet star is very, very hot and has blown off many of its layers mostly hydrogen. And when it impacts the interstellar medium a certain way, it causes it to glow. And so we see this star will become a supernova someday. And that alone is something that's really worth looking for. I want to see a supernova. I really do. I want to see a star blow up. It's just not, ours can't do it, but I don't want one too close. But there's no stars that, if they go supernova, that could really hurt us. Maybe one or so, but you know, it's not going to do that. So we got plenty of time here. But this is a really cool object. You know, this one you saw before, this is a Supernova Remnant that's in Cygnus. That's directly overhead in August. At 9 o'clock, that's directly overhead in August. This is right near it. This is another remnant of a dead star, and that little dot in the middle, you see that's a white dwarf star. Its temperature is, you know, tens of thousands of degrees, and it's so hot that ultraviolet energy is causing oxygen and hydrogen in this cloud to glow. That used to be the star's atmosphere, and it was popped off by the star as it got older. Here's a beautiful nebula. This is called, well, as you might imagine, the North America Nebula. Okay, Florida, Mexico. This thing here is a really cool object. It's a dense knot of gas and mostly dust. And here's a little mental thing to to note. When you see this dark sky here, you're thinking that is a void it's a void in the stars, or a void in the dust, a void in the glow. Actually, it's not. It's dark dust between you and the glow behind it. Because you see this stuff right here? This is overlaying the nebula. So that's the dark stuff's up here in the front, and the bright glowing nebula is back here. So when this dark stuff's in the front, it blocks it. And you can see that that's exactly what it's doing right here. This stuff is overlaying it. And it's not just a visual thing. We can tell from spectra that that's going on like that. And so this is the North America and the Pelican Nebula right here. These are known as stellar nurseries, or H2 regions, H Roman numeral 2, because ionized hydrogen, okay, is what's called it leads to a hydrogen alpha, which is that glow of the red you see. And H2 is ionized hydrogen. That's how you note it. All right. So that's a very beautiful nebula. This is another one. This is a well-known stellar nursery in the summer sky. This is the Lagoon Nebula. Look at that. And it's in a region that is completely full of dust. This isn't bad for a 20-second photo, is it? That's what we get out there. 20 seconds. And the scope is not a massive telescope. It's a 10-inch telescope, you know? So it's just beautiful. You can see lots of little dark nebulae in here. These dark objects are where stars will eventually form, possibly. And sometimes they actually contract and will form not just stars, but planets. And so we're looking at a stellar nursery, but we're also looking at a planetary nursery too, possibly. Now, you saw the Andromeda Galaxy from before. Again, this is 2 million years old, this image. We're seeing the light from 2 million years ago because it's 2 million light years away. And the light at the speed of light took 2 million years to get here from there. So space is vast. There's no doubt about it. Space is vast. You saw the Hubble Space Telescope. It made the Pillars of Creation image, and that's what these are, the Pillars of Creation. We re-imaged them with our telescope, and this is what we got. It's just a beautiful location in the Milky Way. Again, dark nebulae. This bright cluster is evaporating these pillars, and what I'm saying by evaporating is the stellar wind blowing out from these stars is pushing away gas and dust, leaving behind little tiny strands. That's why they're going all in the same direction, like little fingers. This is actually called the Eagle Nebula. There's the Pleiades, okay, with their dust clouds around them. It's just a beautiful location. This is coming up soon. After midnight, the Pleiades are pretty high up. So more dust clouds in the universe, and they just go on and on. The hits keep coming. So what I'd like to have you do eventually is check out our observatory, SkyTour LiveStream, east and west, pictured here. The east on the right is being redone as a square building like that, but bigger, because we were, like I said, we outgrew the other one. And check us out. And I think what you'll find is that we're not the Hubble Space Telescope, but we are twin telescopes that will bring you the universe like you've never seen it before. I want to thank you for joining me